In this video, we're going to look at probability questions, which have a crossover with counting permutations, which you've kind of seen already, so I've left those questions out of this video. The net below is folded to make a fair dice. What number will be opposite the number 7? So 5 will go down alongside number 7. 3 will be alongside number 7, as will 8. And 4 will fold sideways to be alongside number 7, leaving 1 to go on the bottom. So the number 1 will be on the bottom here. The dice is rolled once. Find the probability that the number rolled is greater than 6. Well, this is 0. You can't. Oh no, hang on. It's not a fair dice. We have a 7 and an 8 here. So we have 2 possibilities to be greater than 6 out of a total of 6. So 2 over 6 or 1 over 3. Read the question carefully. The dial is rolled 60 times, so this is relative frequency. We just multiply this by the probability of it happening. So what are they asking us? How many times would you expect an odd number to be rolled? So we have a 1, a 3, a 5, and a 7. 4 odd numbers out of 6 multiplied by 60. And this will give 60 divided by 6 is 10 times 4. We would expect 40 odd numbers. So the following 3 terms are used when discussing experiments in probability, outcome, sample space, and event. Write each of the 3 terms in the table below to match the description. So what do we have? The set of all possible outcomes is the sample space. Sample space for the first one. One possible result is an outcome. And a subset of the sample space, a collection of one or more outcomes, is the event. So this is the coin flip 3 times. Each time you can get heads or tails. So there's 2 outcomes each time, 2 by 2 by 2, or 2 to the power of 3. So there's 8 outcomes in total here. Complete the table below by doing each of the following. Write in the missing letters. Okay, so we've head, tail given. Head, tail, head given, so this has to be tail. Head, tail, head, tail. Head, tail, head, tail. Then we have to write in the 5 missing outcomes. So this is H, H, T. And you can see H, T, H is given to us. Then we have H, T, T. And come and start, all starting with T now, these bottom 4. THH is given, then THT, then TT are both of the last 2. The first one is H, the last one is TTT. Number of heads in each one: 3, 2, 2, 1, 2, 1, 1, 0. And what do they ask us next? So each outcome is equally likely. Fill in the table below to show the probability that Jared gets each number of the given heads. So how many have no heads? That's 1. Probability 1 over 8 is the total. 1 head, we have 1, 2, 3. So 3 over 8 have 1 head. Similarly with 2, it should be 3 as well. 1, 2, 3. 3 over 8 have 2 heads, and 1 over 8 has 3 heads. Head, head, head. Fidelma flips a coin 8 times. Each time she can get heads or tails. Write down the number of outcomes that have no heads. Well, how many have no heads? You can see it up here. No heads has 1 outcome. The number of outcomes we're just asked for, so it's 1 here. The number of outcomes that have exactly 1 head. It's the same question. 3 outcomes of 1 head. And the total number of outcomes when she flips the coin 8 times is 2 to the power of 8, which is 2 to the power of 10. If you don't want to use your calculator, is 1024, as you all know. 2 to the power of 9 is 512. And 2 to the power of 8 is 256. Now we have a box containing red and blue pens. The probability that a pen is picked at random from the box is red is 2 over 7, so it must be 5 over 7 for blue. Write down 3 possible values for the number of red pens in the box. So we don't know how many red pens, so there could be 7 pens in the box. 7 pens, and then they have to be multiples of 7. There could be 21 pens, there could be 14 pens, and so on. It could be any amount of pens. So if there's 7 pens in the box, 2 of them are red. If there's 14 pens, 4 of them are red. If there's 21 pens, 6 of them are red. Find the probability that a pen picked will be blue. We've done that already. We identified immediately 5/7. Why can't there be 20 pens in the box? Well, it's not divisible by 7. Just write not divisible by 7. And some green pens are put in so that 25% of the pens are now green, and 1 pen is then picked at random from the box. Find the probability that the pen is blue. Give your answer as a fraction in its simplest form and show all your workings out. So we don't know how many pens. If we take the first example of 7 pens in the box, we have, if we write out red, blue, green, we do a little table. We want 25% to be green. So if we have 2 and 5, it's 2 and 5. So that's 9. So if we add 3 green pens, that would be 12. 3/12 is a quarter, which is 25%. So that will work for us actually straight away. We could do it with any of them and make it up to 25% green, but that's definitely, no, sorry, that's 10. That's not going to work. That's 2 and 7. 5 is 7 and 3 is 10. I'm adding them up wrong. So that would be 3/10. That's 30%. So it can't be that one. So let's try the next one where there was 14 pens. 4, 10. That's 14. So if we want a quarter of them, if we add 6 this time, that would be the same ratio. So it can't be that. So 14, if we add 5, would be 19. If we add 4, it would be 18. So I'm not seeing an immediate 25% green. Let me try the next one. 21 pens will be 6, 15. So he's 21. So for 25% of them to be green, we'd need to have 20. We could have 7. Could we? 7 will bring us up to 28. 7/28. That would work. That will work. So we go back to the first one. Just imagine this example: 2, 5, 7. So for it to be a whole number, for it to be 25%, it can't be 25% of 10 because you can't have 2.5 pens. 12 would be the nearest number. 25% of 12, 25% of 8. Well, we could have 1 green pen. 20. That would be just a cool. That would only be an 8. So it has to be higher than that. So 7. We can't really get 25% there. You can see that. So it's just trial and error, really, working your way down. There are mathematical ways to do this, but I think logically you can get to the answer quicker. So if there's 21 pens and we add 7 green, we get 28, and 25% of them are then green. So the odds of blue would be 15 out of the 28 that are now in the box. And is that in its simplest form? That is in its simplest form. So here we have a question. Paul is raising money for charity. He organises a fun day where one of the games is played using the spinners as shown. And the rules are: pay €1 to play the game and you spin both. And if you get the same number on both spinners, you get €1 back. You get your money back. And if you get 8 on the 2 spinners, you get €8 back. Wow. Okay, let's have a look here. We'll have to complete the two-way table to show the sum of the numbers of the 2 spinners. So 1 on each spinner will give a sum of 2. And you can see the pattern here. 2, 3, 4, 5, and 6. You can see the numbers 1, 2, 3, and 1 to 5. 2 and 1 is 3. 2 and 2, 4. 5, 6, 7. And then 4, 5, 6, 7, 8. So each outcome in the two-way table is equally likely. So find the probability you'll get €8 back if you play the game once. So how many outcomes have we got here? We have 15 outcomes, 3 by 5. 15 outcomes. My sample space has 15 outcomes. And find the probability that you get €8 back. Well, if we get a sum of 8, we get €8 back. So there's only one outcome there, isn't there, for €8? Sum of 8 has to be 5 and 3. There's no other option. So the chances of getting €8 back are 1 out of 15 to get €8 back. and 320 students play the game. So this is relative frequency. 220 by the probability of something happening will be our answer. They get €1 back, and €1 back is the same number on both spinners, so that will be a 1 and a 1, a 2 and a 2, or a 3 and a 3. There's no other two numbers the same. The 4 and 5 are not on the other spinner. So there's 3 chances out of 15 of getting €1 back. That's the same as 1 over 5. So a fifth of 320 is 64 students would expect to get €1 back. Just type this into your calculator. Now we have 320 students played the game. 74 got €1 back. What's 74 times a euro? Give it 74 euros. Paul made a profit of 110. The profit is 110. Find the number of students who got €8 back. So just double check how much it was to play. Euro. So his revenue is 320. He's got 320 euros. He gives back 74 to the 74 winners. That's going to leave 250 minus 4, 246 euros. And he keeps 110 of it. So take away the 110. We'll leave 136. And how many 8s are in 136? Going to have 17 8s in there, so 17 1 €8. In part E, Paul says the probability of someone getting money back would decrease if he changed spinner B so that it went from 1 to 6 instead of 1 to 5 and kept the rules the same. Is he correct? Make a two-way table using the change spinner B. Okay, two-way table. We have 1, 2, 3, 4, 5 and 6, and we have 1, 2, 3. Let's try and do it as neat as possible in an exam. And let's see what we have here. Not much difficulty in the maths, just in the filling out of the table. I change colors. So we can get a 1 and a 1, so we can get 2, 3, 4, 5, 6 and 7. We can get 3, 4, 5, 6, 7 and 8. And we can get 4, 5, 6, 7, 8, 9. So let's have a look at the question now. Paul says the probability of someone getting money back would decrease if he changed the spinner. So what was the probability of them getting some money back? It was 1 over 15. Well, we actually 1 over 15 plus 3 over 15 if we want to look at it like that. So there was a 4 over 15 chance of them getting money back. Let's see what that is as a decimal. 4 divided by 15. 0.26. Repeating. So 26% chance of them getting money back on the first one. So the rule is if they get the same number on each, so still your 1 and your 1, your 2 and your 2, and your 3 and your 3, or €8. So there's now another €8. So there's now 5 out of 18 chance of winning. And 5 divided by 18, look at it as decimals, it's easier, it's 0.27, so it's a higher percentage. So is he correct? So we would say here that Paul is not correct, as 27% is higher than 26%, so people have a better chance of winning with the extra numbers. The coin getting flipped 3 times has come up quite a few times. We've seen it already in this video. Complete the table below. Head, 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 tail, head, tail, head, and beginning with a head, head, tail, tail, and then we can just reverse the letters. So T, 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 H, T, H, T, and T, H, H. For all the outcomes, 2 heads and 1 tail. Well, 2 heads and 1 tail, let's circle them. 2 heads and a tail. 2 heads and a tail. 2 heads and a tail. There's 3 of them out of 8 outcomes. Jamie says you have the same probability of getting 3 heads as you do of getting 2 heads and 1 tail. Well, that's not right. No, we don't agree. 1 over 8 for 3 heads is not equal to 3 over 8. Max says you have the same probability as HHH as you do of getting HTH. When you do, we agree with Max. It's in this particular order. So yes, there's a 1/8 chance of that. That's equal to 1/8. So yes, we do agree with Max in this case. So learn all the possible outcomes with this coin getting flipped 3 times, and you'll find this question really easy if it comes up. The last question in this video, another relative frequency kind of question. A dice is getting thrown 600 times or tossed. The results are recorded. We have a missing number, so these numbers all add up to 600. Just type into your calculator 600 minus 92 minus 101 minus 115 minus 98 minus 105. And the answer for number 5 should be 89. I think it's coming out as. Just double check. 89. After looking at the results, and claims that the dice is unfair. Well, sorry, I said unfair, unbiased, which is actually fair. So yes, let's have a look here. So 600 divided by 6, we should get about 100 of each number. Do we get about 100 of each number? It's pretty close to me. I think, yes, I would agree. Yes, all very close to 100 is what I would write here. You're never going to exactly get 100 of each. They're all very close to 100. And then if the dice is tossed 300 times, how many times would you expect to get an even number based on the data in the table? Okay, 101, 98, and 105. Add them together. We'd expect to get 150, wouldn't we, approximately? If it was tossed 300 times. Should expect to get 300 if it's tossed 600 times. So let's see what these numbers add up to. 105. So if 6, that's 304. So we'd expect half of that, 152, which is pretty close to your 150. So that's our reason. We're giving numbers as the reason. Or you could just say 150. The dice is fair. We'd expect to get 150. 152 is based on the calculations, but I think either one of these answers would have been marked correct in the exam.